Dang, Mrs. Contreras, that Gandalf the Grey outfit is spot on. Bravo. Let's go ahead and get started with Unit 6, Lesson 5, double and half angle identities. In the previous video, we talked about the sum and difference identities, which you might sometimes hear as the sum and difference formulas. And they were sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Sine of A plus B, sine of an angle plus another angle is equal to sine of the first angle. Ooh, I fixed my my pen nib, but it's still kind of bad, so a little concerning. Sine A plus B, sine cosine plus cosine sine. All right, sine, cosine, cosine, sine. We don't say S-I-G-N. Cosine, 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 sine. We change the sign. Sine, sine. All right, we stick with that alphabetical thing going there. If I put a minus there and a minus there, I just put a minus there and a plus there. Right? That's what we did last time, the sum and difference formulas. Today we do the double and half angle formulas. So we need to derive these things. We need to figure out what, this is our double angle formula, sine 2 times an angle. And we want to use what we know to derive the future. The idea with all of these identities is they start with that geometric proof of cosine alpha minus beta. And then we derive the cosine alpha plus beta from that. Then we derive the sine alpha plus beta, etc. We got the tangents in there. This is all coming from that first geometric proof, geometry, the power of geometry. All right, so now that I've been, yammering a little bit, hopefully you've thought about how to derive the sine 2 theta formula. And the way we do this is we just break that theta up into theta plus theta, which is our first our first sum formula, sine alpha plus beta, sine theta plus theta. Sine, right, there's a dead spot in my drawing pad. That's why this is happening. Sine theta, cosine theta, right? The same theta, right? But it's the first theta and the second theta. Sine, cosine, cosine, sine, and that's our formula. Right, sine theta times cosine theta plus sine theta times cosine theta. That's just 2 sine theta cosine theta. Sine 2 theta is equal to 2 sine theta cosine theta. That's our first identity. That's our first double angle identity. Cool. Sine 2 theta is equal to 2 sine cosine. 2 sine theta cosine theta. Now, this is a good time for me to remind everyone that your job here is not to memorize. There's one thing I think you should memorize, and that is this just amazing song. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. I don't know if I'd call it a song, but that's all you got to do here is know that. And then we can rederive all of the formulas from that original identity. All right, so there's your first double angle. Let's get a cosine 2 theta. So cosine 2 theta, we're going to prove it in a very similar way. Cosine theta plus theta. And for cosine, it's cosine, cosine, sine, sine, sine. Cosine of the first angle. Cosine of the second angle, which just happens to be the same as the first. Sine, sine, sine. Right, it's very inconvenient that the dead spot on my drawing pad is in the place I like to write the most. But it also makes sense of why that's the dead spot. I press down on that spot the most. All right, so we got cosine, cosine, sine, 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 but the angles are the same, so we can combine. Cosine squared minus sine squared. I really don't like that it's so darn messy. That's going to bother me like crazy. Let me write it over here. little better over here. Cosine squared theta minus sine squared theta, right? Cosine 2 theta is equal to cosine squared minus sine squared. Now, that should just ignite sparks in your brain. Cosine squared, sine squared. We can go further. Think about how you can simplify our cosine double angle formula. Cosine squared theta is equal to 1 minus sine squared theta. That's a Pythagorean identity. And with that said, we have 1 minus sine squared theta minus sine squared theta. That's 1 minus 2 sine squared theta. Cosine 2 theta is equal to 1 minus 2 sine squared theta. That's particularly nice because if you want to know what cosine 2 theta is and you happen to know what sine is, you can go straight from sine to cosine. Cosine is related to sine without another cosine. And we can go one step further. We can turn that sine squared theta into 1 minus cosine squared theta. And then now we have a 1 minus 2. That's a minus 1. And a minus 2 times, that's a 2 cosine squared theta. Cosine 2 theta is equal to 1 minus sine squared theta, but it's also equal to 2 cosine squared minus 1. This is like a triple identity. 4 things that are equal. We have a cosine 2 theta, which is equal to cosine squared minus sine squared. The order matters. You know, subtraction is not commutative. But that's also equal to 1 minus 2 sine squared theta, which is also equal to 2 cosine squared minus 1. We have like a super extended identity here. Cosine 2 theta is equal to cosine squared theta minus sine squared theta, which is equal to 1. I'm not going to say it again. All right. I'm actually going to get rid of all my circles just because it's a little messy. But I want you guys to kind of remember this because we're going to come back to this later in this video. We're going to come back to this later in this video. All right, we do have a tangent double angle formula, and it's not that exciting. I mean, it might be exciting. It depends on who you are. Tangent theta plus theta is equal to tangent 1 sine tangent. All right, tangent 1 sine tangent, which simplifies to 2 tan theta over 1 minus tan squared theta. So nothing crazy happening there. It's just, you're kind of squishing together everything in the original tangent formula. All right, the most important one here, they're all important. They're all useful in different scenarios, but this one right here is going to help us later. So try to remember that, the cosine 2 theta formula and how it diverges into 3 separate formulas. All right, no reason to memorize these, but if that floats your boat, then you can. All right, cosine 2 theta has 3 identities. Cosine squared theta minus sine squared theta. All right, don't forget, all of these just derive from sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And just having the same angle in the sum formula. So cosine squared theta minus sine squared theta. We also have 1 minus 2 sine squared theta. And we have 2 cosine squared theta minus 1. Over here, we have 2 sine theta cosine theta. That one's nice because there's no squares going on. And then the tangent one, 2 tan over 1 minus tan squared. All right, so there are some formulas, but once again, don't commit too much of your brain space to memorizing these. Commit as much brain space as you need to remember sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Let's keep going. All right, let's use these real quick. All right, nothing too complicated here. We want to evaluate cosine 2 theta, and we're given the sine theta is equal to 3/4. That's very convenient because cosine squared has an identity in terms of sine. 1 minus 2 sine squared theta. That, I believe, is the second one I wrote. Yep, number 2, right here. And we know what sine is. It's 3/4, so we're pretty much done. Right? This is going to be a really useful tool. 2 times sine theta squared. Sine theta is 3/4, so 3/4 squared. And then now we just do a little bit of evaluating. Right? We didn't even use this other piece of information that it's in the first quadrant. Doesn't matter. We're squaring. Right? 9/16 times 2, that's 9/8. 1 minus 9/8. 8/8 minus 9/8. -1/8. There is our answer. -1/8. Right? Not too bad. Right? We could have used any of the other 3 formulas. Cosine squared theta minus sine squared theta. And 2 cosine squared theta minus 1. However, we were given sine theta, so that's the one that we wanted to use. Right? Use the one that makes the most sense. Right? These formulas, they're very useful. And a lot of people get tripped up in later courses, like calculus, because they don't know these formulas. Hey, hopefully, drilling into your brain, sine, cosine, cosine, sine, cosine, cosine, sine, 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 makes these a piece of cake. And if you haven't noticed, I'm continually drilling in sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. That's very intentional. All right, let's keep going. Tangent, tangent, 1 sine, tangent, tangent. Tangent. But it's a double angle, so 2 tan. 1 sine, tan squared. Right, we don't know what tangent squared is. We don't know what tangent is. This is where we're going to use that other piece of information. We are in the first quadrant. Sine is 3/4. I'm going to give myself a little picture. Sine is 3/4. That means opposite is 3/4. Hypotenuse is 1. Right? We can use the Pythagorean theorem to find this side right here. What I'm going to do is a little dilation, multiply by 4. This is going to be the square root of 16 minus 9. The square root of 7. So tangent is opposite over adjacent, 3 over root 7. This is the angle theta. 3 over root 7. Multiply by root 7 over root 7, and we get 7 under 3 root 7. Maybe simplifying like I did isn't the best move, but whatever. 2, we just evaluated tan. 3 root 7 over 7 all over 1 minus 3 root 7 over 7 squared, so 949 times 7. Right? The 7 and the 49 are going to simplify to a 1 over 7. Right? And I could keep going, 2, 3 root 7 over 7 all over, what's that going to be, -2 sevenths. But I'm going to stop there, and I'm actually going to let you simplify a little bit further. Cool, let's keep going. All right, we got a few more formulas here, right? The half angle identities. The half angle identities. Now this is a little bit more annoying because the double angle identities, those are pretty nice. They were, boom. You just split that 2 up into theta plus theta and then used sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Now we want a formula for sine theta divided by 2. Well, let's kind of stroll up and look at these two identities right here. Cosine 2 theta is equal to 1 minus 2 sine squared theta, and cosine 2 theta is equal to 2 cosine squared theta minus 1. I want to do something. I want to do an aside. I want to derive some other formulas that are not actually written in this document. They're called the reduction formulas. reducing sine squared into something that doesn't have a square. Reducing cosine squared into something that doesn't have a square. And it comes from these two circled identities. Cosine 2 theta, 1 minus 2 sine squared, and cosine 2 theta is equal to 2 cosine squared minus 1. Let's scroll down here. And then, you know what, let's use a whole new page. Shouldn't take too long. Here we are. Right? We have cosine 2 theta is equal to 1 minus 2 sine squared theta. And we have cosine 2 theta is equal to 2 cosine squared theta minus 1. We are going to work out the reduction formula. The reduction formula. And I'm actually going to move all that down a tad. The reduction formula. These are actually particularly useful. You'll have to wait and see. You'll have to wait a year and a half to see why these formulas are so common and useful. But if I do a little bit of shuffling, over here, if I subtract 1, cosine 2 theta minus 1 is equal to negative 2 sine squared theta, divide by negative 2, sine squared theta is equal to, I'm going to do a couple lines here, minus 1 divided by negative 2. Right. I'm going to just take this negative and move it to my numerator. Sine squared theta is equal to 1 minus cosine 2 theta divided by 2. That is our first reduction formula. It takes sine squared theta and then spits out something that doesn't have a square in it anymore. Yes, it turns the angle into a double angle, but it reduces the power. Right? And it turns out in calculus, trying to do calculus on something with a square is quite difficult, but doing calculus on something that doesn't have a square is still difficult, but easier. This is the reduction formula, a useful tool in calculus. This is precalculus. All right, I'm going to move around this other equation and add 1. Divide by 2. Cosine squared theta is equal to cosine 2 theta plus 1 divided by 2. And then I'm going to go one step further. And I am going to make it look like my 1 on the left. I'm going to move the 1 to the left. Oh, that's all I'm doing. Right, sine squared theta is equal to 1 minus cosine 2 theta over 2. And cosine squared theta is equal to 1 plus cosine 2 theta over 2. All right, that is our second reduction formula. If you're given in the future cosine 2 theta and you'd like there to be no square, you can just turn it into 1 plus cosine 2 theta divided by 2. Right? If you think about it for a second, these two values are always going to be positive. There's a few ways you can think about it. The left-hand side of both my two equations is being squared. So the left-hand side will always be positive. Therefore, the right-hand side must always be positive. That's the first way you can think about it. The second way you can think about it is, even though there's a 2 here, cosine is never bigger or smaller, never bigger than 1, never smaller than negative 1. So 1 minus 1 gives me 0, and 1 minus negative 1 gives me 2. So the numerator here is always going to be between 0 and 2. Right? 0 and 2. And then divided by 2, that brings us back to being between 0 and 1, which is the range of sine squared. Similarly over here, 1 plus something that's between negative 1 and 1, our numerator is always going to be 0 or positive. Divided by 2, still positive. So these are the reduction formulas. And these are going to be the key to our half-angle formulas. Let me rewrite the reduction formulas. Sine squared theta is equal to 1 minus cosine 2 theta divided by 2. And cosine squared theta is equal to 1 plus cosine 2 theta divided by 2. We want a formula where we can evaluate sine theta divided by 2 using a reference angle, using just pi over 6, pi over 4, pi over 3, multiples thereof. And the trick here is to use the reduction formulas. Think about it for a second. I'm actually going to, really quick, change my argument over here to like, let's go with b. Very arbitrary. Sine squared b is equal to 1 minus cosine 2b over 2. Cosine squared b is equal to 1 plus cosine squared b over 2. What I'm going to do is I'm going to replace b with theta over 2. And let me actually do that here. Sine squared theta over 2 is equal to, I'm going to write b is equal to theta over 2. Sine squared theta over 2, that is just an angle. That is going to be equal to 1 minus cosine, that angle multiplied by 2. Theta over 2 times 2 is just theta, divided by 2. I want a formula for sine theta over 2, not sine squared theta over 2. So I got one last step. Square root both sides. Now when you square root both sides, you got to be careful. Plus or minus the square root of 1 minus cosine theta divided by 2. Now you may ask me, what do we do with this plus or minus? It all depends. Where is the angle theta over 2? If theta is, let's say, 10 pi over 6, 11 pi over 6, you divide that by 2, whoosh, you're going to find yourself in the second quadrant. If you have an angle here, theta, and you divide that thing by 2, you're going to find yourself in the second quadrant. And sine in the second quadrant, always save the crust. Sine in the second quadrant is positive. So you would then choose the positive angle. We'll do an example in a moment. Right, so that plus or minus needs to stay there. Right, that is our half angle identity. That is a tough one to memorize, and I actually have a song for this one that I will not be singing. But I'm going to link it in the description below. So if you want to listen to the song, hit pause here and go to the description below, and then there's going to be a hyperlink to a different YouTube video of a student singing it a couple years ago. It was on InfoFlow. Right, I will not be singing the song, though. But if you want a song for the half angle identity here, check the description below. While you're there, don't forget to like and subscribe. However, let's proceed. I will not be singing that song. Right? Cosine theta divided by 2, very similar process. Cosine squared theta divided by 2 is equal to 1 plus cosine 2 times the input angle, which is just theta. Theta divided by 2 times 2 is theta, all divided by 2. And then for our half angle formula, we're going to square root. We get plus or minus the square root of 1 plus cosine theta divided by 2. And with that said, same angle up here. If I were to plug in an angle in the fourth quadrant into my cosine theta divided by 2, the divided by 2 will bring it to the second quadrant. Half of a fourth quadrant angle is a second quadrant angle. And cosine of a second quadrant angle, always save the crust, that's going to be negative. Cosine's negative in the second quadrant. So you would choose the negative one if the theta that is given is a fourth quadrant angle. if you're given a third quadrant angle, I think half of a third quadrant angle is still in the second quadrant, so the output would be negative. If you're given a first or second quadrant angle, half of that will be the first quadrant, where both sine and cosine are positive. So you choose the positive one. So this plus or minus in both these formulas is just choose. Choose the correct sign for the angle that you were given. Right, but there are your half angle formulas. And in the process, we also get the reduction formulas, which are particularly useful in the future. All right, but for our course right now, we're going to hone in on these half angle identities. 1 minus cosine theta over 2 square rooted. 1 plus cosine theta over 2 square rooted. Okay. We do have 1/4 theta divided by 2, and it's kind of nice actually, because we're going to combine these two. Tangent theta over 2, just like we did last time with Mrs. Contreras. That's just sine theta over 2, and cosine theta over 2. And we have those formulas now. Plus or minus the square root of 1 minus cosine theta over 2 and 1 plus cosine theta over 2. Right? The formula is going to get nicer than that. But that is your tangent half angle formula. The tangent ones are always less pretty. Or are they? Let's do a little bit of simplification, some algebra. Let's turn this big square root, these two square roots into one big square root. The square root of b over the square root of a is equal to the square root of b over a. Facts. So let's go ahead and do that. Plus or minus the square root of 1 minus cosine theta over 2 all over 1 plus cosine theta over 2. Right. These 2's are going to cancel. Don't believe me? Just multiply the top and the bottom by the reciprocal of the bottom. These will cancel, and then we'll have a 2. The 2's are going to cancel. I'm just going to go ahead and cancel them, though. I think I've gone far enough. Cool. Plus or minus, the 2's are going to cancel. The square root of 1 minus cosine theta over 1 plus cosine theta. All right. Notice how I've left a lot of room. That was intentional. Right, this is our first tangent half angle formula. There's actually more. Tangent theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. And you choose the plus or minus based on the angle that you're given. So if you're given a fourth quadrant angle, you're going to end up in the second quadrant when you chop, which is going to be tangent is negative in the second quadrant. Always save the crust. But if you chop a second quadrant angle in half, you're going to be in the first quadrant, which will be positive. So this is all about choosing. But with that said, whenever I see a 1 minus cosine theta or a 1 plus cosine theta, I think to myself, Pythagorean identity. Let's get ourselves a Pythagorean identity. How do we do that? We've done it before. Multiply by the conjugate. We've actually done this identity move before when we were studying identities for the first time. 1 minus cosine theta, 1 plus cosine theta. I was setting you guys up to be able to make sense of this really easily. Let's multiply by 1 plus cosine theta over 1 plus cosine theta. On the top, I'm going to get 1 minus cosine squared theta. On the bottom, I'm going to get 1 plus cosine theta quantity squared. Plus or minus. 1 minus cosine squared theta, that's sine squared theta. Let me actually give myself some more room because we're about to be simplified. 1 minus cosine squared theta. I keep doing that. That is sine squared theta over 1 plus cosine theta squared. Let's square root those things. The square root of a square is absolute value. So no matter what, we're going to be left with positive sine theta over 1 plus cosine theta. All right, sine theta over 1 plus cosine theta. And then I shouldn't have been so shouldn't have hogged so much space with this one because we multiplied the top and the bottom by 1 plus cosine theta. We could have multiplied the top and the bottom by 1 minus cosine theta, which is what we're going to do now, 1 minus cosine theta. The top is going to become 1 minus cosine theta quantity squared. The bottom is going to become 1 minus cosine squared. Continuing along, we're going to have a 1 minus cosine theta over 2. 1 minus cosine squared theta, which I did it again, which is just sine squared theta. Right, and then the square root's going to get rid of those. Right, but sine 1 minus cosine theta and sine theta, we're going to be good. Boom. All right, we don't have these absolute value bars because these plus or minus are canceling out. It's a little bit complicated, but we have 3 formulas for theta divided by 2. I know there's a lot going on here. I know it's a little bit overwhelming, but don't forget that the goal here is that all you know is sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And then we're just building these formulas based on that fact. For these two, I like to remember that 1 plus cosine theta goes on the bottom for this one, because 1 plus cosine theta is on the bottom here. And then 1 minus cosine theta is on the top because 1 minus cosine theta is on the top here. Little ways I remember it. You don't have to use what I'm saying. Right. Plus these are you'll have these written down. Tangent theta is equal to 1 minus cosine theta over 1 plus cosine theta, rooted, plus or minus. The plus or minus actually goes away for the other two. Sine theta over 1 plus cosine theta and 1 minus cosine theta over sine theta. Just little ways I remember it. I'm just going to write them down here. We have plus or minus the square root 1 minus cosine theta over 1 plus cosine theta. Then here I have the 1 plus cosine theta on the bottom. Here I'm going to have the 1 plus minus cosine theta on the top. And then a sine theta on the bottom there and a sine theta on the top there. That's how I remember it. It's kind of silly. Not the best. The sine half angle ones, though, that's going to be plus or minus the square root of 1 minus cosine theta divided by 2. And this one's going to be 1 plus cosine theta divided by 2. Right? And let me just double check that I didn't write it down incorrectly. 1 minus cosine theta goes with the sine. 1 plus cosine theta goes with the cosine. Nice. And that's because the cosine 2 theta had a minus with the sine and a plus with the cosine. And those are there because cosine squared theta was in the front of sine squared theta in the cosine double angle formula. This all just goes back to the cosine, cosine, sine, sine, sine. Right? All of the formulas that we've written down here stem from sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. All right, so half angle formulas, how do we use them? This is pi over 8. Let me write this as a half angle, pi over 4 over 2. And then this is going to be plus or minus the square root of 1 plus cosine theta divided by 2, where theta is pi over 4. And the question is it plus or minus? Take a second to think. The final answer better agree with the original given problem. Cosine pi over 8, is that positive or negative? Here's a cosine graph. Pi over 8, which is like right here, totally going to be positive. All right, so we're going to go with the positive one. Positive the square root. My square roots are just not that great today. Sorry, everyone. 1 plus Cosine pi over 4, that's root 2 over 2. Divided by 2. I'm going to stop writing the positive. Let's see, we have 2 plus root 2 over 2 all over 2. So we're going to have over 4. 2 plus, at this point I'm just doing some standard simplification. And then we're going to have a 2 on the outside. 2 plus root 2, all rooted. There's an embedded root. That's kind of annoying. Simplification, that's, you know, if you're into it. Right. Tangent 5 pi over 12, same thing. This is going to be a half angle formula. Tangent of 5 pi over 6 over 2. Right? 5 pi over 12 is in the first quadrant. Right? 6 pi over 12 is pi over 2. 6 pi over 12. So 5 pi over 12 is going to be like right here. We're going with the positive value. Tangent is positive in the first quadrant. Right? So plus or minus, we're going with the positive one. The square root of 1 minus cosine theta over 1 plus cosine theta. Positive cosine of 5 pi over 6, that is going to be, where's that going to be? That's going to be over there. Cosine is negative root 3 over 2. Negative root 3 over 2 plus root 3 over 2, because we're subtracting, minus root 3 over 2. This is our answer. Right. We could have used one of the other formulas. So we have 1 minus cosine 5 pi over 12, sorry, 5 pi over 6 over the sine of 5 pi over 6. Or we could have used 1 plus cosine 5 pi over 6 underneath sine 5 pi over 6. All three of these are going to give us the same thing. And so cosine, so that's going to be 1 plus root 3 over 2 all over sine 5 versus 5 pi over 6. That's 1/2. Oh, I like that. That's going to give it to us right away. Ooh, that's nice. We have a 1/2 there, 1 plus 1 minus root 3 over 2. And hopefully that gives us a 2 plus root 3. I think it's gonna. We can write that as a 2 over 2. Those are going to cancel. We have 1 over 2 minus root 3, which I believe is going to be 2 plus root 3. Multiplied by 2 plus root 3. Let's simplify with conjugates. It's nice to see this again. 2 plus root 3 over 4 minus 3, which is 1. Nice. Equal to 1. 2 plus root 3. All right. Does this top one simplify? Let's see. Write this as a 2 over 2. Write this as a 2 over 2. All the 2's are going to cancel. 2 plus root 3 over 2 minus root 3, all rooted. That's pretty nasty. I'm going to write out the calculator. Let's see if it gives us the same number. The bottom two gave us 2 plus root 3. 2 plus root 3 is 3.7. 3.7320. 3.732. Okay, sweet. All right, tangent can definitely be 3.7, by the way, if you are worried that this was outside of negative 1 to 1. The square root of 2 plus the square root of 3. This is a hard one to type into the calculator, everyone. Sorry. 2 plus the square root of 3 divided by 2 minus the square root of 3 is 3.73. All right, so that one's just annoying to simplify. I'm not a fan. I mean, you're going to multiply by conjugates. You're going to get some, it's going to become 2 plus root 3 written in a different way. But all of these are 3.732. So tangent has 3 formulas you can choose from. Clearly, the bottom 2 were easier to work with. I'm a bigger fan of those anyways. Right? 1 minus cosine theta over sine theta, and sine theta over 1 plus cosine theta. That is it, though. We got a bunch of formulas in this video. How did it go, Gandalf? Mrs. Contreras? Awesome. Wow, I'm so stupid. I'm so sorry. So sorry, everyone. Right, but we got the double angle formulas for sine, cosine, and tangent, and we got the half angle formulas for sine, cosine, and tangent. We also got the reduction formulas on the way, and we did some practice problems on the way, so that's really nice. Right, I'm going to close this one out. But yeah, have a great one, everyone. It is springtime. No, it's not technically springtime, but it's almost springtime. So get outside. The weather's great. Get some fresh air. And I will see you inside on a computer. Or watch this one outside on a computer if you have a laptop. Get some fresh air. That's my words of wisdom today. Have a good one, everyone, and I will see you on the flippity flop.